Hey, everybody, and welcome back to the Level Up podcast. I'm your host, Ken Rose, co-founder and CTO at OpsLevel. OpsLevel is an internal developer portal that helps engineering teams quickly ship quality software. Our Level Up podcast explores challenges, best practices, and stories from some of the brightest engineering and DevOps leaders about what it takes to build great products, teams, and companies. And today we have Phillip Carter on the show with us. Phillip is a principal product manager at Honeycomb. For those of you who don't know, Honeycomb is one of the leading observability tools in the market. Phillip is focused primarily on developer experience and a variety of work on OpenTelemetry, Honeycomb's open source efforts, and their tooling. And with the recent boom in all things generative AI and LLMs, Phillip has also worked with the team to ship new LLM-based features like Honeycomb's Query Assistant and overcoming all sorts of challenges with training and productionizing an LLM at scale. Before joining Honeycomb, Phillip also worked for many years at Microsoft as a program manager working on both F# and .NET. So Phillip, thank you so much for joining us today.
Yeah, thanks for having me.
So I've introduced you a little bit, but I was wondering if you could just tell us a little bit more about yourself and some of the work that you've been doing recently at Honeycomb.
Yeah. So as you mentioned, I was at Microsoft for about 6 years working on the .NET team, and started off kind of in docs, and because there were like no docs for the new version of .NET that we were building, it's cross-platform, and kind of mingled around with languages until I settled into F#, and then worked on both F# general .NET developer tooling, a little bit of C# compiler, kind of bouncing around quite a bit with F#, the language sort of being the primary place that I was anchored, I guess. And we saw the version of .NET, then called .NET Core, then it was evolved into .NET, and the .NET framework, the Windows thing was like kind of cast off as a little bit more legacy. We sort of saw that grow from nothing to about 5 million users, and kind of like a mission accomplished moment in a sense for me. So then I decided to see what other kind of developer tools are out there and available. And I landed at Honeycomb, who are building observability tools, which is like a whole other, it's certainly upstack compared to like languages and compilers, but there's all kinds of different challenges there. And in particular, there was a need to invest in the OpenTelemetry project, which provides telemetry for so far 11 different languages and a whole bunch of different tools to be able to gather really good data from what's running in production, and then you send it to an observability tool like Honeycomb to analyze it and figure what's going on in your code base. And the main challenge there was, hey, it's like this growing technology. It looks like it might be entering like this hockey stick growth curve, and how do we as a company really invest in this long term so that we're both like materially improving the project, but then also like seen as really helping push the project forward itself. Like sort of this, we're sort of in this unique moment where like you kind of have your cake and eat it too from a corporate level of like make something that is good for everyone, not just your customers, better, but also be seen as a better company by trying to advance an initiative that has incentives that are fundamentally customer centric rather than company centric. And so did that for quite a bit. Then LLMs hit the scene. Well, they were there for a little bit, but they weren't particularly useful, or they were way too expensive. And then April of this year, OpenAI reduced their pricing by 2 orders of magnitude for the API. And all of a sudden it was like, oh, wow, the most powerful the most powerful ML models available via an API are now just accessible, dirt cheap. We can just use them now, and I've shifted quite a bit of my efforts, not all of them, but I'd say like 60% of my efforts into understanding this new world that we're in, and also building and shipping features with it.
That's a phenomenal career trajectory so far. I was wondering, maybe I could pick a little bit on some of the OpenTelemetry stuff and a bit of stuff about Microsoft, and I'd love to talk about LLMs because definitely there's that hockey stick growth. I think every company has now had to adopt some kind of stance on like where do they see LLMs fitting in their product offering, and it seems that every week a company's coming out with like, hey, now you can use natural language in this novel way in our product. Maybe you can talk a little bit to us about like just what is OpenTelemetry? What were some of the goals behind it? You mentioned, it's very kind of customer centric. Can you talk a little bit about like the goals that OpenTelemetry has, and how Honeycomb kind of sees itself fitting in with it?
Yeah, definitely. So back in the old days, meaning like maybe 4 or 5 years ago, so not terribly old, most observability tools and APM tools, they all had custom instrumentation, like custom agents, custom SDKs, and if you're using one of them, but then it's not the right tool for you after a year or something like that. You try to expand within your company, it's not getting traction. Like maybe you got a really good deal at first, but now all of a sudden prices are getting jacked up. It's hard to move off. And you can't really explore other alternatives because that implies like a multi-month migration process. Like I mean, there's always the migration of just having a team that knows how to use one tool and move to knowing how to use another tool. But like at the most fundamental level, the data that is being generated that powers that stuff in the first place, it's locked into a particular vendor. And so there were these initiatives called Open Census and Open Tracing that tried to tackle this problem of being like, hey, let's create a vendor neutral standard for generating telemetry from applications that are running. Neither really got deep enough. Like they didn't quite have enough pieces to get really good traction. And so we ended up with this really terrible situation of like multiple competing standards, all of which slightly incompatible with one another, and the vendor specific ones that still had like dominant market forces behind them. And it was not very good. So then several people in 2019 gathered where they were co-founders of like the Jaeger standard, of Open Tracing, Open Census, lots of other people working for vendors and saying, okay, this is a total mess. Like customers are coming in to a particular vendor saying, hey, I have tracing in like 4 different formats and I can't make sense of this. Can you please help? And like it's chaos from a vendor standpoint. And like it's totally not friendly from a customer standpoint because like, come on, that like nobody can make sense of that. So they finally merged projects together and really focused especially on having a lot of really quality broad instrumentation for all kinds of different languages. So like Java and Python and .NET, they all have dozens of packages that instrument like popular libraries that people use. So like in the Java world, you got like your Apache Tomcat and Spring Boot and so on. Python world, you have like your Flask and your Django and all the major languages with all the major frameworks and all the major ways that you actually have apps that interact with one another. They're now emitting telemetry and it's all emitting it in a common standard. The reason why this common standard worked out is because there was just enough force of development activity, especially from a lot of the vendors, to build out componentry that is simply better in aggregate than anything else out there. So now, like you're not really making, I mean, there are a few cases perhaps where you could argue you're making a sacrifice by moving to OpenTelemetry. That was perhaps true about 2 years ago for a lot more people. Now, the amount of features and just capabilities you get with OpenTelemetry typically is far larger than anything you would get if you were to be vendor neutral. And so the feature set just keeps growing and growing and growing to the point where it's like, okay, well, if we want the best observability, we need to generate the best data. And OpenTelemetry is actually just the best at that now. And so there is also, it's not really a side benefit, but almost kind of like the side benefit of being able to key off data to like any kind of backend, potentially competing observability vendors and do like a bake-off competition between them to see which one does better. But like the tools are all there to support that, and the data is good enough such that you can like fill out the UI on each of these tools enough to like really be able to assess how useful they're going to be for you. And that's kind of the trajectory the OpenTelemetry project has been on. And so now when you're at a company and let's say you're going to practice service ownership, where every development team is going to be like, cool, we build the features and we're responsible for them in production. It doesn't matter what language you're using now. You can just add an SDK. It's 1.0 quality. You can just turn on the auto instrumentation. It takes like maybe 5-10 minutes of a developer's time. And boom, you have all kinds of really good data coming out, traces, metrics, and logs. And the traces in particular are really high quality. And everything can just connect to everything. And if you have somebody more on the ops side and they're like, okay, we want to collect this data and maybe normalize it in a particular way or like redact certain information that maybe shouldn't make it out of our network. Again, like there's componentry to do that. It's super easy to set up. It's really easy to configure. It's stable and you can send it off anywhere. And there's still a lot of work remaining in the OpenTelemetry project. There will probably forever be a lot of work remaining because people's needs are going to evolve over time. But it's really matured into a robust solution that people can rely on for this kind of stuff.
So it sounds like for customers then, it allows them to avoid vendor lock-in. It makes it easy to switch vendors if and when they ever want to, or when they're doing kind of bake-offs. It allows for easy rollout in an organization. If I think about a platform team kind of shipping the golden path, we can just sprinkle in OpenTelemetry really easily and have that applied to all of our services really easily. And it's easy to kind of like parse and process the data because it's standardized. And imagine there's a bunch of leverage you get out of that because like, oh, I don't have to write something for this custom vendor. There's probably some other developer in the world that has had this problem.
Yes, absolutely. And I think another thing about why it's so friendly for people to adopt is if at a given organization, if you're like say on an ops team, like maybe your role is like the cluster admin for your Kubernetes cluster, you have tools where you can install instrumentation across all your nodes without having to go and bother a bunch of teams to do it. Now, it might be a good thing to bother those teams. I would argue it actually is, and developers should like really own this, but sometimes the organizational incentives aren't really there to allow that to work very well. But you still have options. And then on the inverse, if you're a developer on a team and you're like really hot on the idea of observability and you're like, cool, I just want to add this to my service and see how that's going to work out. You can just load in an SDK and it's also just as easy to get started. So sort of on almost sort of like opposite ends of the spectrum, like not touching any code and touching a very specific part of code. There's tools and libraries that are stable and available for you to use just immediately. And it takes a little bit more learning because it's not as super like plug and play as some of the vendor options, but it's so flexible that at any point in an organization, you can have pretty much any sized initiative with OpenTelemetry and you can just roll that out. And that's something that talking to a lot of developers and people who are more in sort of the ops side, like app developers and like more ops developer kind of side, both of them see really positive attributes in the project where like these attributes are like fundamentally different, but they work really, really well for the roles that they're playing in these orgs.
That's really interesting. What when I think about this kind of cabal of different vendors coming together to devise OpenTelemetry, I imagine there's almost this tragedy of the commons, right? That can occur where it's like no one vendor really wants to do this because I would think would want to have kind of control over what that format looks like. What do you think made OpenTelemetry sort of successful in that regard? Because there have been lots of other kind of cross-industry things. The web in the early days, there was a lot of fighting between like Microsoft and now Google, and they're pulling the W3C in different directions. What do you think's made OpenTelemetry kind of successful in the sense that these vendors kind of realized we're better off to work together to deliver this customer value?
So by virtue of being built and founded by people who worked at different vendors, there was kind of this I mean, we're all kind of friends, even though we work for competitors. So like we want to get along, we want to find ways to work together that's not going to interfere with our work lives. But really this incentive alignment on the vendor side was sort of acknowledging that, well, none of us really make our money on generating the data. Like that's something that's almost sort of seen as like a tax that you have to pay to be able to use our product in the first place. And so it's like, okay, well, if we're forcing somebody to pay a tax that like they have to pay again and again and again, like that's kind of terrible. And that's not that's not really going to help our business long term. Maybe it's like a short term thing that could really, make us stand out over the course of a year. But if we want to be a successful observability company over the next 5-10 years, then that's just not the right playbook. And so the incentives also really work out there where OpenTelemetry said, hey, we are focused only on the collection and management of that data before it actually gets sent somewhere else. And whatever happens in that somewhere else, we don't care about. It's like, cool, we have this format, you do with it what you want. And that really worked out because we designed that format in a way where it's possible to work for all the different backends. And I mean, like, frankly, it's not too hard to read a protobuf definition that looks like a particular structure and make it fit into your UI. So it was pretty easy for most vendors to adopt. And then I think the sort of there's this other piece to it that is, oh boy, sorry, I'm having a train of thought get lost here. Oh, right, sorry. So another piece to this, which is it continually forces us to invest in not only supporting the project, but also supporting how we absorb like data that comes from the project, is it's got enough of a ball rolling such that new features are coming in and customers want to use those new features. And if we as a vendor are complacent and we say, yeah, we support OpenTelemetry, as of like a year ago, Well, those customers are going to be like, all right, cool. Well, we want this feature. Your competitor supports it today. It takes us 15 minutes to start sending our data to them. What are you going to do about that? Because our contract is coming up. That really lights a fire under somebody's butt to be like, all right, cool, we got to stay on top of this. And that incentivizes us as vendors to continually make our products better with respect to how OpenTelemetry evolves, but then also continue to improve OpenTelemetry and add those features. So it's like this, we've gotten ourselves into this positive feedback cycle where the incentives for vendors are aligned really well, but then the incentives for it's very still customer friendly and customer centric, I think.
Yeah, the customer value, I've no doubt, and almost I think the corporate value is on the one hand, the if you're apathetic, you might say, well, as the vendor, we want to own the one standard, but then that way it's really hard for people to leave. But by having an open standard, it's also really easy to have people come, right? And if you're thinking about like preventing churn versus new customer acquisition, I could imagine there's a lot of value meals that by supporting open telemetry, there's where we can bring in way more customers and worry about other ones leaving us and going to a different vendor.
Yeah, that's totally true. In fact, in the earlier days of OpenTelemetry support at Honeycomb, one of our top customers, Vanguard, literally said us supporting OpenTelemetry was a critical part of them being able to sign a deal. Because they weren't like threatening, hey, we're going to leave if like we don't like you or something like that. I mean, I guess in a sense that's always implicit with any kind of contract, but like, they saw this as like, hey, this is a thing that is friendly for us, and we want to make sure that you're taking it seriously. And if you are, that's going to make us really want to sign with you more. And like, that's not the first time that we heard that. And so I would imagine people working at other vendors have heard the exact same thing.
Right on. Phil, I wanted to talk a little bit about the query assistant feature that you and the team at Honeycomb shipped because I think I'd love for you to talk to us a little bit about how that feature came to be. But it sounds like it was very like kind of lightweight and iterative in the early days, and almost like kind of hack day, right? Where it's just like get a bunch of smart people in the room and ship relentlessly quickly. But could you tell us a little bit about how we went from the explosion of LLMs to you folks at Honeycomb realizing like, hey, this is something we should invest in, and now getting something out the door?
Yeah. So this goes back to October of last year. So I was thinking about sort of like whole product problems that we have. And a lot of the things that we struggle with as a business, or at least certainly had struggled with, especially with regards to new users, is problems that don't really have a single solution, or the solution is like on some probabilistic spectrum of correctness. And it turns out like that's literally what machine learning is designed for, of like, hey, well, I can't give you a guaranteed exact answer that's going to be like 100% correct, but I can give you something that's probably correct somewhere on some spectrum of correctness there, and you need to figure out what that spectrum is going to be and what you're going to show, and there's a whole lot of stuff that goes into that, but we have lots of problems throughout our product that are set up like that. And so I wrote this whole like mini manifesto about how we need to incorporate ML in all these different ways into our products. I didn't actually get into natural language querying at all. I got more into things like recognizing the shape of data that's coming in and trying to create like a dashboard of queries for people based off of the shape of that data. Something we might still go after, but at any rate, then ChatGPT came out, continued to evolve. The API got 2 orders of magnitude cheaper, and all of a sudden now this idea of not say what I want to be queried just in English, because I have my own mental model of what I want to query for my data, and have it generate a probably good Honeycomb query from that, became just eminently possible. And so I just picked that. I'm like, okay, well, that's probably, I feel like I could iterate with that even just by myself. So I did. And after about a month, I came away with a prototype that was looking pretty good. Worked with a developer. He spent like, I think 2 days putting something like really janky in the UI that used our API to show that query, but like it had the end-to-end working of like there was a text box, you could hit enter, just make sure you don't do a whole bunch of different things in this UI, otherwise it would crash. And then you would get a query that was executed, and you could see that, and everybody's minds were like blown. They're like, "Oh my God, this is now possible!" And we immediately shifted. Leadership is like, if you have 2 developers, how much time do you think it would take? And I said, well, if we're really aggressive, we could do it in a month. And they're like, cool, you got a month. That was a ridiculous time frame, but it turns out when you have people who are excited and you give yourselves really just a ludicrously small amount of time to get something done. You really ruthlessly prioritize things, and it's actually great. Like we all worked just like 40 hours a week during the entire time, but it was super exciting work where, everybody was just making decisions about everything every step of the way. And we really rushed as much as we could to get something that was good for what it was, perhaps missing several features that you could argue are kind of embarrassing to miss, but hey, we're shipping to learn.
Right.
And critically, we instrumented the heck out of this thing, where we instrumented all the, like a whole bunch of information about what was going into the inputs, the actual capturing user input, capturing the actual output of the LLM. And then what we do is we parse it into a given structure. And so there's like these like parsing and validation errors that could potentially occur. And so we want to capture all of that. And then there's like this user feedback at the end where if we could successfully execute a query against our engine, you see it. There's like a little thing where you can do like, give me like a thumbs up or thumbs down, or there's like a button called unsure. We basically ask if it answers your query.
Right.
And all of that is correlatable because we used OpenTelemetry to just track that stuff as spans in a trace. And we could then use Honeycomb to then analyze how this thing is doing in production. And so after we initially went live, there was like this little press release thing. Then it was go time because people were using this thing like wild. And oh boy, there were all kinds of problems with it. But I think it really highlighted this idea that like we could never have possibly predicted the sorts of things people are going to put in that text box, and then following up with some of them what they would expect to actually see. And just by actually capturing that data systematically, using like an observability mindset to iterate with something in production, pushing code literally every single day to sort of fix one thing and then take a look at the next 24 hours of data and be like, hey, like did this materially improve what we saw? It improved. We were able to iterate pretty rapidly for about another month and a half until we were able to take the feature out of experimentation. And now it's just a core product offering. We added a whole bunch of like little features that made like the contextual generation, like added context to the prompt that gets fed to OpenAI. There's a lot of really subtle things that we added over that month and a half where the result of, or rather the impetus behind doing that was us looking at patterns in user inputs and LLM outputs, and if there was an error, what the error was, and saying, okay, well, it looks like people are asking like this class of question. So let's focus on that and we'll see what we can improve. And sometimes it got into like, there's this notion of dataset settings in Honeycomb where you can have something like the canonical definition of an error. Well, let's say you have multiple columns that have the word error in them. Which one is the right one to use when you say, what's my error rate? Well, we can't know that up front, but if you manipulate your dataset settings and you say, actually, this one is like what I want to count as the error column always, that's an example of something we can pull in, and we parameterize the prompts to a very heavy extent with this sort of contextual data. And we were able to end up with something that was quite reliable, where now we're sitting at about 97% success rate, which is to say that 97% of the time, and the thing that we're measuring, we get a query that was able to successfully execute based off of somebody's user input. And when we look at the cases where it fails, it's usually like the inputs that they gave were like so weird, and it's like, okay, there's no possible way we could create a query from that.
Right. Like a human would not have fared any better in that circumstance.
Yeah.
To just to understand the problem that it's solving, right? Like, because Honeycomb has its own sort of query language. Is my understanding of the problem is there is a query language that's there. It's just you have to know what the query language is and all the things you can do with it. And instead, just being able to say, Honeycomb, here's what I want. You go figure out what the query to go ahead and build and execute is. Is that a fair summary of how this feature works?
That's exactly it. And to elaborate on that a little bit, one of the core business problems that we have for new users, like people who are, and particularly people who are not coming in through sales, or if like you're working for an organization that is using Honeycomb and we're trying to expand into this organization with other teams, but like you're not necessarily working with a salesperson to like help you teach you how to use the product. You have a mental model of what you want to query usually. But we have this interface called the Query Builder interface that is actually really, really great when you know how to use it. It actually is quite user-friendly. But still, if you're not familiar with tools like this, you're going to look at that and be like, okay, I don't really like, I want to know what my error rate is. I don't know how to express that. And actually, fun fact, the notion of what is my error rate can actually be a very tricky thing to express in a query. And so there's these cases like that where it's just harder than it has to be. And so we have a couple metrics that we track, especially for new users, where we indicate that as like a relatively strong signal that somebody has been what we consider activated within the product. And like if they're a new user coming in through our free tier, if they're activated, then there's a very high chance that they're gonna give us their credit card number for a like a pro tier subscription. And so we're like, okay, cool. Like if we can move those metrics, then we should see a knock-on effect of our pro tier subscriptions go up. And if these people are likely to use the product more and then pay for it eventually, that will likely also hold true for teams that are expanding their use of Honeycomb. So we did that, and that was specifically what we're looking after is creating more complex queries manually. So we want the query assistant to teach you how to use the UI such that you graduate off of it for the most part, because now you know how to use the UI. And maybe you go back every once in a while because you're like, well, it's just maybe a little bit more convenient for me to just express it in English. But by and large, we want you interacting with it, with this thing, because once you have a query in place, it's really, really easy to like click in a box and group by another field or add another visualization or something like that. And if you know that you can do that, then we got you.
Yeah.
And I actually mean that in a positive sense. Like people come to us because they want to query their data, but they don't necessarily know how. And so
Yeah.
we found that after we had been live with the final changes, so no longer in experimentation, we have what we call a complex query, and new users who use the query assistant, about 40% of them went on to create a complex query compared to those who did not use the query assistant. It was only about 20%. So we got about sort of a 2x jump there in terms of people who were activated in this particular way. We also have manual querying retention. So basically after 6 weeks, are you still actively querying your data within the product? There's high chance that after 6 weeks, if you're still querying your data, you're really using our product, and you're probably going to end up paying us some money at some point, if not already like signed up for the pro tier or something like that. It was a 3x jump. For those who used Query Assistant, were 3 times as more likely to be continuing to query after 6 weeks compared to those who did not use the Query Assistant. And so there were some discoverability issues to solve there, because even though we put it sort of right there in the middle of the UI, some people still didn't even really notice that
Right.
Query Assistant was there. But really, really strong signals that it's doing its job at teaching people how to query their data such that they don't actually even need to use the AI anymore.
Right. Something I think about in terms of like documentation systems is that, you can write as much prose as you want, but providing people like useful, actionable examples is the most important thing. And what this kind of feature sounds like, it's you generate your own examples. Just tell us what you want, and then we'll teach you how to get that. And as opposed to like, here's a curated list of examples we thought about, and then you as a developer have to figure out, okay, but how do I take that and get it to what I want? I can just tell you what I want, and then I get the query, and I'm able to learn how to write queries and more about Honeycomb's query language. So that's amazing.
Yeah, it's been a lot of fun to work on.
I wanted to ask, hopefully no surprise for our listeners, right? Lots of companies experimenting with LLMs. We're experimenting with LLMs here at Ops Level. Any lessons, Phillip, that you and your team found in terms of like how to develop with this new tool? Because in our experience, it's a little bit different, right? I find programming languages are more deterministic. It's like, hey, I have this thing and I wrote this method and it does this exact task. And it's more, one of our developers referred to it as alchemy, right? It's kind of like, well, you don't really know what's going to happen. You tweak the input. So any lessons that you can share from working with the team at Honeycomb on like how to develop with LLMs?
Oh yeah, we learned a lot. So first of all, we are definitely in a bit of a Wild West space right now with prompt engineering. So prompt engineering, for those who may not necessarily be familiar, is the idea that you have these what are called pre-trained LLMs. They're these super powerful ones, like the ones that OpenAI offer. And you don't need to like train a version of that model or whatever first before you could ever use it. You can actually just literally give it instructions, perhaps even with examples embedded in those instructions. And that does what's called steering the model towards a particular kind of output. And there's all these techniques for how you do that. It's literally just a text file that you pass it. It's sort of like giving somebody instructions. And so, as you might imagine, depending on who you're talking to as a person, different instructions are going to work differently for different people. And there's all these different techniques that you can try to like get people to do a job better. Well, it's the same principle with a model. And so there's lots of different techniques. Different techniques are better for different use cases depending on how much contextual data you add in and what the kind of task it is you're trying to perform, whether you're trying to have it create like a JSON blob or freeform text, or if you're wanting it to summarize like a block of text or rewrite something, or given this code, can you like rewrite it to do this other thing or something like that. There's almost like an infinite number of use cases. And so through prompt engineering is how you get these models to create the outputs that you want them to create. But there's like no frameworks for it. There's no really any best practice. There are some best practices that are kind of emerging right now, but a new one pretty much comes out every week. It's really on you to experiment with what's actually working best for you. We found that out pretty quickly. We found that for our use case, retrieval augmented generation, or RAG, was really, really important. That's how, if you have a big chunk of data that you want things to operate on, where you're like, hey, cool, this is the data that we're working with. You basically stuff that data in all kinds of creative ways into your prompt, and you sort of like assert, hey, this is the basis that we're operating under, and here's like the rules for how you work in that data. And then we found that if you embed a bunch of examples of like, given this input, this is what the output is, given this input, this is what this output is, and so on, you can steer the model pretty effectively into reliably producing a particular kind of output. And then you get into an iteration phase. And so this iteration phase, I think really, really critically, it makes more acute the problem of like, you're not going to find out what's going to work until you actually go live and you have people like unprompted using the thing in their own ways. Because just to give you an example of this, of how you can't predict what's going to happen, is one of our customers who uses the feature quite a bit. They paste these expressions in Honeycomb. It's called a derived column expression. It's this DSL that we have inside of our product that's used for something completely different than query. Like it's for this thing for creating a column, a computed expression based off of existing columns that you have in your schema. And there's a DSL for it. And it never occurred to us that somebody would just paste expressions, custom expressions from that DSL into the query assistant and try to get a query out of it. Like, it's something that in my head makes absolutely no sense. Like, here is this language for creating a column and you're wanting a query out of that? What? But it worked. And not only that, we looked at the data and they hit the yes button several times saying that this answered their question. There's no way we could have predicted that up front. We were like, what the hell? Like, why? First of all, why would anybody do this? But second of all, wait, it works? And so like, that's kind of wild. And then we had a lot of the inverse cases where people were adding a bunch of inputs where we didn't think to really test that. And we're like, oh yeah, wow, that is totally the wrong answer. I could see why it led to that wrong answer, but like, crap, we got to fix that. And you just, given enough users, you can't do this. So like, this is true for pretty much any kind of software, really. Like, if you want to really know how it's going to do well, you got to get it out there. But with LLMs, it makes that far more acute because you can't unit test the stuff. It's really hard to do system integration tests in general. You can't debug it and see how it's like step by step emitting this token, and here's the reason why, and here's like the space of all of the tokens that were available, and like, ooh, yes, it selected that one instead of that one, because there's literally like billions of tokens that it could select from. So like, you can't use the traditional tool set for making these software more reliable. Like, you don't have as much of that when you're doing this stuff. So you have to go live, and we learned very quickly you have to instrument everything about inputs, as much metadata as you can, and everything about outputs, and as much data as you can about what the actual outputs were and like what the errors were, having rich errors rather than just like, whoops, we failed. And correlating all of that stuff so you can sort of group things together and slice and dice based off of, okay, if I hold true that show me everything that's an error, but now spread that out based off of user inputs. Let's look at what the space of user inputs were over this period of time. That's when you're going to be able to see what's actually going on here. And there's a lot of other approaches and tools that are kind of emerging for trying to bring some of that into local development. For better or for worse, I think we'll have some kind of tool set like that, but there's still no substitute for getting something out and into people's hands and letting them just abuse the crap out of it, and very rigorously looking at what they're doing to it and seeing what the outputs are, and then using that as your basis for iteration. that's I think that's sort of the key takeaway that we had.
Yeah, we've had a very similar experience, on our own team here, where we do a bunch of stuff in dev local, right? And it's like, hey, we think about what are the use cases our customers might have, but yeah, when you actually put it out there and you get that real data coming in, you're like, oh yeah, didn't expect that one, right? And how do we like steer the model? What do you think are some of the biggest hurdles that teams are going to face then in terms of developing LLMs? Like, is it small context sizes? Is it lack of kind of existing tooling that parallels, more traditional development environment? You pointed out like it's hard to debug and it's hard to understand what's going on. Is it lack of patterns or idioms? Like, what do you think are some of the largest hurdles that teams face today?
So I think it's going to depend on how reliable you need an LLM to be. So I talked with someone who is working for an insurance company, and they have a very low tolerance for unreliable outputs. So in their case, their challenges I don't think are going to be getting stuff live and iterating. Like that's still going to be a challenge, but that's actually kind of the easy part for them. The hard part for them is going to have rigorous evaluations of the LLM to be like, okay, based off of all of these kinds of outputs, how are we going to actually grade this stuff? And how are we going to decide whether or not we need to intervene on an output before we produce something that could be like factually incorrect? Because if you're factually incorrect in the world of insurance, well, that could mean like loss of life. That could mean lack of care. That could mean losing a whole bunch of money. Like there's very real consequences for that, and so it's going to be really hard because you almost want it to be deterministic, even though it's inherently non-deterministic. And there are ways you can get very, very closely, but then that's when you start needing to pull in ML engineers and data scientists who are really good at ML model evaluations. If you're just like, I would argue most product engineering teams, you probably don't have super high consequences for something being like kind of incorrect. And
Right.
so you probably don't need to go that deep into model evaluations, which is positive. But then like there's still quite a bit of a like in the observability space, we're finding the biggest problem is not necessarily selling people on a tool. It's getting teams to get comfortable with the idea that for certain classes of software, debugging really means gathering data, gathering telemetry from something that's live, diagnostic information, systematically analyzing that and using it as a roadmap for being like, okay, this is the problem space that we should be focusing on, or we just push this database migration or something like that, and this is how the database is now performing. That's hard for a lot of teams to do because a lot of software traditionally has just not really been in that. Like, I would argue that people who are more on the DevOps side of things are more familiar with this kind of stuff, but increasingly a lot of developers who are writing just product engineering code, they need to start caring about this a lot more. LLMs makes that problem a lot more acute, kind of what I was talking about earlier, where since you can't debug it and you can't unit test it, you really want the only good option you have available is to measure this stuff with instrumentation and see what's happening, and then pull that data back into development and say, okay, these are like the cases that we're going to work on. And whether you could find a way to turn that into test cases, I don't really know. Maybe there's going to be some tools that come out for that. But that mindset shift of we're shipping to learn and we're iterating in production, we're testing in production, but like we're doing it intentionally rather than unintentionally, which I think most teams are kind of actually doing today. This makes that need to do that much more acute, and that's going to be a big hurdle for people to go over. However, I think that there's sufficient motivation to do that because the capabilities that these LLMs provide are so high that it's worth it for teams to like change their practices to accommodate that.
Yeah, it definitely. I love your point about you have to be way more metrics focused. I also love just the observation, like you folks, it sounds like are using Honeycomb as the system, like as the metric system, basically to evaluate like the efficacy and the accuracy of like the queries that are getting generated. But being able to have that tooling as a first class thing that's part of your development cycle to be able to better iterate on these features.
Yeah.
Um, Feel free to get kind of as pie in the sky here on this next question, right? What role do you kind of see LLMs and machine learning, play in improving developer experience and developer tooling overall? Like, I'd love for your take, given you had years at Microsoft also working on developer tooling. Is there the kind of vision painted by a lot of futurists is like at some point regular software developers as we know them, they won't exist. Everyone will be a prompt engineer. What's your kind of take, between software development today and that maybe, I don't know, dystopian future of how LLMs are going to improve developer experience?
Yeah, I whenever somebody says that software development is going to go away, I roll my eyes back into my head as hard as I can that they like they flip back around like integer overflow or something. There are so many things that developers spend so much time on that they should not really be spending time on. And on top of that, there's just so many things that a business wants to get done but cannot ever get done because there's just simply not enough time and not enough people. And so I think first and foremost, regardless of what the tool set is, we're going to be able to emit more software just because we're going to have better tools for automation. And so digging into that a little bit, I think one of the really cool areas that's being invested in right now that I would really love to see is automated code migration assistance. Like there's so many organizations out there that are still like moving to TypeScript, and future work is on hold because like we need to get the reliability of this code base intact, and to do that we need to move to TypeScript. But then it takes like 6 months, and it's like, okay, like we're still not getting stuff out the door, and there's all kinds of other refactorings that go on where, you know, a lot of them fail because they take too long. And it's not that like there's a lot of points in those places where it's difficult, and you have to make a really good judgment call on if this is the right thing to do or not. But then there's a whole lot of space of just mechanical crap of like, now we got to change this file and this file and this file. And it's like, we already know what we're doing now. It's really almost sort of like this pseudo automated thing, but there's no tool that can automate this for us. So we have to spend a ton of time doing this. I think we'll see LLMs take the place of that chunk of that. You know, you make the decision, it's able to interpret the decision correctly. You have this sort of feedback loop of being able to be like, hey, does this look good? And eventually it can sort of tune its outputs to the point where you could probably reduce the time it takes to do a code base refactoring by an order of magnitude. That's something that I would really love to see. We already see coding assistants like GitHub Copilot and SourceGraph Cody and some others that make the actual writing of code a little bit faster. One thing that this is going to do is it's going to push the bottleneck in software development towards code reviews and debugging. Because right now, code reviews are still line-by-line text code reviews. You could argue a lot of developers don't even really review line by line. They just kind of slap the merge button.
It looks good to me, and then off we go.
And to an extent, it also places more stress on test writing. And so I think first of all, we're gonna see LLMs or LLM features that are hyper specialized on writing really good unit tests, but then also integration tests. Because that's often where the trickier stuff lies, is not necessarily that this tiny component is doing its job, but that the system as a whole is actually kind of doing things. Right now, it's hard to write good integration tests. And again, it's a very toilsome thing. A lot of it is like lots of boilerplate copy paste, and then you're like, oh my God, I hate this. Wouldn't it be nice if I could just like make this whole testing system? But then it balloons into a whole sort of thing. And if you could have something that automates that as much as possible, then you could have more of those tests, and you could feel more confident in doing things like reviewing that, hey, let's say this change that was 50% automated by an LLM, I can actually have more confidence that it's actually doing the right thing. On the debugging side, I think this is where I'm a little bit less clear of the role that they're going to play. Because right now, I just got done saying you can't like debug LLMs, but if you're debugging your own software that's not using LLMs, you can use still a traditional debugger. But there's opportunities for AI assistance there. I think in particular if you have like a big old megla method with like 1 million variables in it or something, some sort of thing that's able to sort of statistically highlight like, hey, here are like perhaps the 10 most important variables that you should be looking at this point in time. Right now, there's nothing that does that, so you have to do that all by yourself. Or being able to probabilistically evaluate expressions inside of a method and say like, hey, if the code runs through these branches, this is what these values are going to look like, and find some way to massage that data and present it in a way that you don't have to step by step through everything necessarily. You could perhaps even as like a first pass see like, hey, this is what it's going to look like. Do you want to move on? Or do you want to like continue and really validate that this is what's going on? That's something that could be pretty interesting in the debugging space. But like, I think it all centers around the creation of the code itself, the app code that does the thing that you want, is going to be ever more automated. But then the systems for validating that it's actually doing what it should be doing right now are going to be stress points, and I think parts of those can be automated, but then I think that really highlights that there's pieces of that are judgment and decision making, where humans are still the best at this sort of thing, likely always will be, at least certainly for quite a while. I'm not a believer in AGI, by the way, so that's like I don't see that really replacing us in any way. And so we have quite a ways to go, I think. And I think the developer tool space is going to see a lot of innovation because of that. Because just because you make the writing of the code faster doesn't mean these other parts that are critical to the business are going to get faster either. And so that calls for new tools, that calls for new practices, also calls for people who are working on LLMs to see if they can improve those bottlenecks as well.
Yeah. So it sounds like we're all still safe. Like as us developers out there, we also have a job at least for the next, maybe 10, 20 years. But help, being able to see innovation in debugging and boilerplate, all the boilerplatey, toily things, and having, LLMs being able to replace that so that we can get back to like the important bits of like, how does the system work together, and not worrying about like, I got to do all this setup and tear down for this integration test. I got to migrate this particular, one library across, this gigantic code base. Well, Phillip, listen, before we wrap up, I always like to ask our guests, what is your favorite music to listen to?
Ooh, I'm really digging some of the abstract hip hop that's come out this year by Billy Woods and JPEG Mafia. But I have a little bit of an eclectic music taste. I jump around between bluegrass, abstract hip hop, post rock, death metal, black metal, kind of anything. So
Cool. I'm gonna give both those a listen later this afternoon. It's actually this is my favorite question because it kind of like figures out my Friday afternoon jam. And so, Phillip, also, what is the best way for people to kind of follow you on the internet or on social media?
yeah, so I'm on Twitter, x.com/Twitter, whatever, at _ Carter MP. I also have my website, phillipcarter.dev, where I really should be blogging more. I've been promising myself I would do that. You can also email me at pcarter@fastmail.com, or my work email, phillip@honeycomb.io. And I'm always happy to chat about all things developer stuff.
Awesome. Well, everyone feel free to follow Phillip on X or his blog or his email. We're going to be including all that contact information in the show description below. And yeah, today we talked about OpenTelemetry and, productionizing LLMs and the future of LLMs and software development. So Phillip, it has been absolutely great having you on the show, and really appreciate you taking the time. Yeah, and to all our listeners, thank you again for making it to the end of another episode. If you have any topics or guests you'd like to see on the show, please reach out to us at levelup@opslevel.com. See everybody next time, and happy building.